Hello students, welcome back to the channel Maths Insider. In today's video, we're going to learn about the Fundamental Theorem of Arithmetic or Prime Factorisation. So what you will learn from this video is what is the Fundamental Theorem of Arithmetic, what Prime Factorisation means, and how to solve the exam question easily. So watch till the end. So let us understand the basic idea of prime factorization. So any composite number that can be written as a product of prime numbers. So if there is any composite number that can be written in the form of product of the prime numbers. Now we already know what is composite number. So the numbers which have more than two factors. So the two factors, more than two factor means like 1 and the number itself. Other than these two factors, there will be factors more than that. So for example 8, we have 2, 4, 8 and 1, etc. So 8 is a composite number. Whereas in prime number is the numbers which have only two factors, that is 1 and the number itself. Example, so we take 5, 7 and so on. So 1 and 5 are its only factor. Now let's get back. Let's take an example to find the product of prime numbers. So we have taken 12, which is 2 times 2 times 3, and we have 18 whose factors are 2, 3 and 3. Hence what we find is that from these two numbers, so we find that this whole process is called the prime factorization. So how we have break the numbers into its prime factors, and the whole concept is completely depend on these fundamental ideas. So the theorem is based on these ideas. So let's take a glance to this fundamental theorem. So this fundamental theorem of arithmetics, and what does this say? So this says that every composite number, we have learned what is composite number, that can be expressed as number 1, the product of prime numbers. So we can able to express it in the form of prime numbers, product of prime numbers, and that expression of the product of prime number will be in a unique way, and except for the order of the factors. So order of the factors can vary, but it will be always the unique way of by which the prime factors will have the product. So let's understand this in a very simple words. So every numbers, we can take any number that can be broken into the prime numbers in terms of their product, and these are the factors of that particular composite number or any number, and the factorization is always unique. Only the order can be changed. So we can change the order. So let us take an example to see this fundamental theorem, and we'll try to prove that. So let's find the prime factors of say 24. What we can do, we can use the division method. Say step 1, 24 divided by 2 is 12. Again 12 divided by 2 is 6, and 6 divided by 2, 3, and 3 divided by 3 is 1. Or we can also do it in a different way. 2, 12, then 6, then 3 gives 1. So what are the factors of 24? Step 2. So factor of 24 is 2 into 2 into 2 into 3. And what we can write, 2 to the power 3 into 3, because there are 3 2's. So we have expressed in terms of the power. And this product of this prime factor of 24 is the only prime factorization of 24, and this is very unique. We cannot write it or express it in any other way. That is why the uniqueness is coming into picture. Number 2, only we can change the order. So therefore, what we can see, that 24 equal to 2 to the power 3 into 3, or we can just change it 3 into 2 to the power 3. So we are just changing the order, but the factorization remain unique. So this proves the fundamental theorem of arithmetic. Now, important exam tips. So state the fundamental theorem of arithmetic. If this kind of question comes, we can state, and we should remember to write the statement very clearly, and we should also state the word unique factorization, which is very important, and we can give one example to prove it. So let us quickly revise what we have done so far. So what is fundamental theorem of arithmetic? So what we have learned? We have learned that every composite number can be expressed or written as a product of prime numbers. So we can able to express it as a product of prime numbers, and the factorization is always unique, so we cannot change that. Only we can change the order of factorizations. So in the next video we will going to learn how to find HCF and LCM using this prime factorization.